So again, there's no test this week, right? Okay. All right. So 2.7 is inverse functions. So inverse functions, we'll talk about the definition of the inverse. If two functions f and g are said to be inverses provided f of g of x equals g of f of x equals x for all x in the domain, then g can be written as f inverse of x. So remember in the last section where we said g of f of x and f of g of x are not equal, right? Well, in one situation they are equal, and that's when they're inverses. And they should equal your variable. So this f inverse, this is the worst notation in math. If you look at this, sometimes people will think this is f to the negative 1 power, and they'll say it's 1 over f, right, with properties of exponents. That's not true. This is the functional inverse, not the multiplicative inverse. So, worst notation in math. But somebody wrote it a million years ago, and here we are. So another way to say this is f of f inverse of x equals f inverse of f of x equals x. So that's the definition of an inverse. So functions are inverses if the composition in any order is equal. So determine if the following functions are inverses. So we need to look at that definition and see what we get. So we need to do composition. If we do f of g of x and we get x, right, then we're done. We can either do f of g of x if that equals x, or g of f of x if that equals x, right? Either one. We don't have to do both. But if it equals x, they're inverses and we're done. So let's check. So number 1, f of x equals 5x and g of x equals x over 5. So let's do f of g of x. And this is exactly what we did last time. First step is write down the definition. Then I'm writing what g equals. Right? Just plug in what g equals. And now I'm taking x over 5, and I'm plugging that into f wherever I see an x. So I get 5 times x over 5. Okay, so multiplying fractions, what do you get? Or just simplifying, right? 5 over 5 equals 1, so here you get x. So that means that they are inverses, right? Because the composition equals just the variable. So yes, they are functions. Because f of g of x equals x. All right, number 2, h of x equals 3x minus 7, and f of x equals x plus 3 over 7. So why don't you guys try that one on your own? You can either do f of g of x or g of f of x. You guys do it on your own. I'll do it up here. How do you know if they're inverses? If the composition equals x, right? So if the composition equals x, then they are inverses. If you get something else, anything else, they're not inverses. So do the composition and see what you got. Okay, so I'm going to write mine up here, but only look if you need help. So what? I can't simplify this anymore, right? So I did f of h of x. So I wrote down the definition, h of x equals 3x minus 7. And then I went to my f. Wherever I saw an x, I put 3x plus 7. And that's as far as I can simplify it down. It does not equal x, so they're not inverses. Right? Maybe you did h of f of x, and you got something different, right? Whatever you got, it was not x, so they're not inverses. Is that clear? Are we good? What did you get if you did h of f of x? Did anybody do that one? I did it and I got this is what I got for that. Still doesn't equal x. Not the same. Right? So either way you do it, doesn't equal x, so they're not inverses. Okay? Okay, so now let's do the steps for finding inverses. So step 1 is replace f of x with y. Step 2 is interchange x and y. Step 3 is solve the equation for y. And step 4 is replace y with f inverse of x. So we're going to be given functions, and we're just going to go through those steps in order to find the inverse. So determine the inverse for each of the following functions. Okay, so I'm given f of x equals x plus 5. Step 1 is replace f of x with y. So I'm going to write y equals x plus 5. Step 2 is interchange x and y. So I get x equals y plus 5. So instead of writing y, I wrote x and vice versa. Now step 3 is solve the equation for y. So if I have x equals y plus 5, how do I solve for y? I need to get y equals, right? Y equals whatever. It doesn't matter. Just solve for y means y equals. So I'm going to subtract 5 from both sides. I get x minus 5 equals y. So I have y equals. So I'm done solving for y. I've completed step 3. So step 4 is replace y with f inverse of x. So f inverse of x equals x minus 5. So if you're on a test and say this is a multiple choice or a free response and you want to check your work, you can go back to that definition and see if f, so to check, you can say f of f inverse of x equals x if you want to check your work, right? It's always good to check your work on a test. If you want to check your work, this is how you check it. If you get it equals x, you got the right answer and you're done. It's an easy way to make sure you get 100, right? Okay. Number 4, k of x equals x minus 1 squared. Okay, so step 1 is replace f of x with y. Here we have k of x. It doesn't matter what our function is called, right? So I'm just going to write y equals x minus 1 squared. Step 2 is interchange x and y. So I'm switching x and y. Okay, step 3 is solve for y. So who can help me solve this? What do you think, Brady?
Sorry?
I thought you were saying something.
No.
Okay. How do I solve this? What? I would take the square root of both sides. Right? So let me write that as an extra step. Okay? Now I add 1 to both sides. So what do you guys think of this? Oops. So because my function started as k, I'm going to write k inverse of x equals the square root of x minus 1. So are we good? Yes, thank you. So are we good with this? Does everybody agree? All right, we're going to come back to this problem, number 4, in a few minutes. Okay, number 5. I have h of x equals x cubed plus 3. So why don't you guys try it on your own? Follow the 4 steps above. So did I get it right? So I could have either done the cube root, or I could have done x minus 3 to the 1/3 power, right? So the cube root and the 1/3 power are the same. So I'll write that as an or, just in case people did it. Okay, so did everybody get this? Are we good? Okay, let's do number 6. Do you guys want to try it on your own? So number 6 is m of x equals x squared plus x. So you guys try it on your own. Okay, what do you guys think? Did anybody solve number 2? Solve for y? It's not possible, right? I can't get y equals. If I have y squared plus y, I can't get y by itself for this, right? So don't make stuff up. This is not possible. I cannot solve for y, right? I cannot complete step 3. If you factor out a y, you get y times y plus 1, and then what? Nothing. You cannot solve this. I've put this question on a test before. Sometimes people just make stuff up to get an answer. You cannot do it. So m of x does not have an inverse. So it's important to check your understanding, right? So you're not making things up. Okay? All right, so then let's go to number 7. So number 1, 3, 4, and 5, they were polynomials, right? So they were a little easier. Number 7, we're dealing with rational functions, right? Rational always means fraction. So the way we solve these two is going to be similar as well. Okay? But it's the same exact steps. So step 1 is always, so let's do 7 together, and then you guys can try 8 on your own, okay? So number 1 is always replace f of x with y. Here we have g of x. It doesn't matter what our function is called. And then step 2 is interchange x and y. So I get x equals 2y minus 3 over y plus 1. And then step 3 is solve for y. So who can help me? Who has an idea? So in order to solve for y, I need to get everything with a y on one side and everything without a y on the other side, right? But I also have a fraction, so the best way to get the variable out of the denominator is to multiply by the least common denominator, right? That's what we did. I don't remember what section it was. So to get the variable out of the denominator, we multiply by the least common denominator, right? So let's multiply by y plus 1. So we're multiplying by the least common denominator. That's how we get the variable out of the denominator. So here I have x times y plus 1 equals 2y minus 3. Okay, so I'm going to distribute my x. And I get xy plus x equals 2y minus 3. So now I can get everything with a y on one side, everything without a y on the other side, right? So I'm going to subtract 2y from both sides. And I'm going to subtract x from both sides. So are we good? Did I make any mistakes? Okay, so how can I get y by itself? Because here I have xy, here I have minus 2y. Who's got an idea? What if I factor out a y from the left-hand side? Then I have y times some other stuff, right? So let's do that. So I have y times some other stuff. I can divide both sides by that other stuff, right? And now I have y by itself. Okay, so the last step is, instead of y, I'm writing g inverse of x. So this is my answer. What's another way this answer could show up? I could factor out a negative from the numerator, right? And put that negative in front. So these are both good answers. So see how I factored out that negative from the numerator, right? Because if I have negative 1/3, that's the same thing as negative 1/3. It's the same thing as 1/-3. So I can put the negative wherever I want. If I have the negative in the numerator, I can take it out in front. Right? Okay, so let's talk about the steps. So we did step 1 through 4, right? But this was a fraction, so how was it a little bit different? Well, I did step 1. Instead of writing g of x, I wrote y. And then step 2, I replaced x and y. But then I had to multiply by the least common denominator, right? Multiply by the least common denominator and distribute. So once I distributed, or once I multiplied by the least common denominator, on the left-hand side, I had to distribute my x, yeah? And then I got everything with a y on one side and everything without a y on the other side. And then I factored out a y and divided, right? So I want you guys to try number 8 on your own. I'll write down my answer and only look up if you want to check, but really try to do it on your own. So number 8 says f of x equals 3 minus x divided by x, or divided by 3x minus 1. So what do you guys think? Did I get it right? Okay, so let me talk about the steps. So step 1 is replace f of x with y, right? I'm just going back to this chart here, step 1 through 4. Replace f of x with y. Step 2 is interchange x and y. So for step 2, I had x equals 3 minus y divided by 3y minus 1. And then because I'm dealing with these fractions, I have a variable in the denominator. I multiply by the least common denominator, right? Multiply by the least common denominator and distribute. So now I'm solving for y. That's part of solving for y, step 3. Then on the left-hand side, I'm distributing my x, multiplying my x times 3y minus 1. Did everybody get to here okay? Yeah? Good, because that's half the battle with these fractions is remembering to multiply by the least common denominator and then distributing. So then from this step, I get everything with a y on one side and everything without a y on the other side. So I'm not writing out all those little details anymore, right? So I'm adding y to both sides. I'm adding x to both sides. I get 3xy plus y equals x plus 3. And then on the left-hand side, because the goal is to solve for y, I factor out a y on the left-hand side. Then I have y times some stuff. Whatever that stuff is doesn't matter. I just divide both sides by that. Here, when you get to this point, make sure you only have the y equals and you don't have any other y's on the other side. Right? In order to solve for y equals everything without a y. So I get my answer and I replace y with f inverse of x, which is my step 4. So are we good? Were there any parts that were a little tricky? So it's just going through, to find the inverse, it's just going through those 4 steps on the previous page. If you have a fraction, it can get a little trickier, but this is the pattern. What we did in number 7 and number 8, there's always the same pattern for the ones with fractions. Okay? So let's go on to B. The horizontal line test and one-to-one functions. So function f passes the horizontal line test provided no horizontal line intersects the graph more than one time. So that's graphically, if we're looking at a function f, if it passes the horizontal line test, right, side to side horizontal line, it only intersects the graph one time. Not twice, not 3 times, just once. Then we have the definition for one-to-one. A function f of x is one-to-one if every element in the domain corresponds to only one element every element in the range corresponds to only one element in the domain. So what's the range again? What's the range? Good. The range is possible y values, right? And what's the domain? Possible x values. Good. So let's read this again with that. So the function f of x is one-to-one if every y value corresponds to only one x value. So that's another way to say it passes the horizontal line test. These are saying the same thing. The horizontal line test is looking at a graph, right? If I draw a horizontal line, one-to-one, so here's another mathy way to say it, right? One-to-one is the exact same thing. So these are the same. Right? If I drew a picture of this, every y value corresponds to only one x value. It's saying it passes the horizontal line test. And then the existence of inverses, like why are we talking about the horizontal line test? Why are we talking about one-to-one? because we're talking about inverses. A function f of x has an inverse f inverse of x if and only if f is 1 to 1, or another way to say that is if f passes the horizontal line test. Okay? So functions only have inverses if they're 1 to 1 or if they pass the horizontal line test. Very important to know. So let's determine whether the following functions pass the horizontal line test or if they're 1 to 1. Okay? So number 9, we have h of x equals x squared plus 3. We just finished graph transformations, right? So what does x squared look like? A u. It's the parabola, right? X squared plus 3, what does that plus 3 do to my parabola? Takes it from having the vertex at 0, 0 to what? I hear whispering, but I'm not sure. 0, 3? So it shifts it up 3 units. If I'm adding and subtracting on the outside of my main function, that shifts it up or down, right? Okay, so what do you guys think? Does this pass the horizontal line test? Is this 1 to 1? Well, draw a horizontal line and see. Here, I have a horizontal line. It intersects my function twice. So the function f passes the horizontal line test, provided no horizontal line intersects the graph more than one time, right? Well, I just drew a horizontal line that intersects the graph more than once. So this is not, it does not pass the horizontal line test. It is not 1 to 1. So what does that mean about its inverse? It doesn't have one. Good. Okay, what do you think about number 10? If you're not sure, you can graph it on your calculator, right? I don't know if I brought my calculator. So let me graph it on my calculator. I have x divided by x plus 2, or x minus 2, sorry. Okay, so what do you guys think? If I draw any horizontal line, am I intersecting the graph at more than one spot? No, I'm not. Here it might look a little tough, and this is why calculators, it's hard to rely on calculators, but here, we'll talk about it soon, but this is a horizontal asymptote, but it does not intersect the graph at more than one spot. What do you guys think? Was that a lot? What do you think, Brady? What do you think?
No, I agree. I'm explaining it.
Okay, but let me know if you have a question. So let's bring this back to the first page. Because if we know that x squared is a parabola, let's look at number 6. Number 6 is x squared. That's a parabola, right? So that's why we cannot find the inverse. What does that mean about number 4, though? Number 4, I have x minus 1 squared. That's a parabola too, right? So mathematically, we found one, but it does not exist. So you can't just go through the steps 1 through 4 and do it. You have to be thinking about, is this 1 to 1? If I have x squared, that's a parabola. That's not going to be 1 to 1. So this is bad. Not 1 to 1. So no inverse. So make sure you're looking at that along with the 4 steps, right? So make sure you cross out number 4. If you guys came in late, let me know, right?